Good evening, everyone. I will just wait for 2-3 more minutes so that more students can join. Then we will start the session. So let's start today's session. So I'm your TA Vidushi and today is a problem solving session 4. Am I audible? So in this class we will discuss about Raman spectroscopy. So a spectroscopic technique used to observe vibration, rotational and other low frequency modes in a system. So basically generally there are two types of scattering, that is elastic scattering or it can be inelastic scattering. So it can be either elastic or it can be either inelastic scattering. Now, an incident photon of energy h mu raises the molecule from a vibration state to one of the infinite number of virtual states located between the ground and the first electronic states. The type of scattering observed is dependent on how the molecule relaxes after excitation. So, here you are seeing there are different energy levels, and when molecule goes from ground state to the excited state, suppose upon excitation, the frequency is mu I, and when it returns back to the ground state and it relaxes to the same energy level, then the frequency is mu s. So then the scattering is called as Rayleigh scattering. In that case, E is equals to h mu. Now, when a molecule is excited to a high energy level or any other virtual state and relaxes back to the ground state, lower than the original state, then it is called as Stokes scattering. Here the energy is equals to h mu minus delta E. Another type of scattering is anti-Stokes scattering, where a molecule goes to the excited state and it reacts back to the ground state, that is high energy. So here this will be mu I, and then the frequency corresponding to here it will be mu s. That is scattered frequency. So energy will be equal to h mu plus delta E for the anti-Stokes scattering, and energy will be equals to h mu minus delta E for the Stokes scattering. So just remember, when the molecule is going to the excited state and in return back to the original state, then it is Rayleigh scattering. When it comes back to the lower the energy, then it is Stokes scattering, and when it is coming to the higher energy state, then it is anti-Stokes scattering. Now here if you see the right hand side, this is a Raman spectrum of CCl4. So the y-axis is the intensity and x-axis is your Raman shift. So the one shown with the higher intensity is your Rayleigh scattering. The left to the Rayleigh scattering is your Stokes line, and the right to the Rayleigh scattering is your anti-Stokes line. Or the left to the Rayleigh that having a lower wave number is your Stokes, or we can say higher wave number and right of the Rayleigh scattering is your anti-Stokes line. So just remember, when we talk about the Stokes, then delta mu will be equal to mu naught minus mu s. So it will be the frequency of the incident photon and mu s will be the intensity of the scattered photon. So this is for the Stokes. And when we talk for the anti-Stokes, then your delta mu will be equal to mu s minus mu naught. So this is the anti-Stokes line. So these two you have to remember. So this is for your empty stock and this is for stock style. Now, what is Ramanship? The position of the Raman lines are expressed in in terms of the Ramanship. So here it is defined as per the following equation: delta mu bar is equals to mu s bar minus mu naught, where mu s and mu naught are the wavelength or the wave numbers of the incident of the source radiation and the observed scatter lines. It is obvious that the Raman shift of the stock lines would be positive, while for the anti-stock it would be negative. Why negative and why positive? Because here on excitation it is returning back to the state which is low in energy, and in anti-stock it is returning back to high energy. Higher in energy, that means it is negative, and lower in energy, that means positive. Therefore, positive and negative signs are there. So just these two formulas you have to remember. Now let's solve some questions related to Raman scattering. So, what type of interactions between the EMR and matter is studied in Raman spectroscopy? Transmission, absorption, reflection, scattering. Anyone? What will be the answer? Khalida Banu, Moses. What will the answer to this? Which type of interactions between the EMR and matter is studied in Raman spectroscopy? Transmission, absorption, reflection, or scattering. So it will be scattering. The next, which of the following depicts the correct order of intensity for the below transitions? So out of this relay, anti-stroke and stroke, which will have higher intensity, we already discussed just now. Anyone? Anyone? See, in the previous slide we just discussed the high intensity is your relay scattering. The one to the left of the relay scattering and having lower wave number is your stock line, and one to the right of the relay scattering and higher wave number is the anti-stock line. So we know relay is the highest one. So option B and D will be eliminated. So after these two, stock and anti-stock, which will be higher. So it will be relay, stock, and then anti-stock. Moving to next. Overturns and fingerprints are observed at near IR, mid IR, or far IR. So what will be the answer to this? Anyone? What are overtones basically? I'm audible. I'm audible. So basically, what are overtones? Overtones are a result of absorption of light at high energy level than that of the fundamental frequency of the molecular vibration. So they are generally seen in the near IR region. That is your 1400 to 600 centimeter inverse. So that will be the correct one. And fingerprint, we already discussed that in IR you will have two regions. One is fingerprint region and another is functional unit region. So fingerprint region we see in the near IR region. Next, according to Hooke's law, which of the following will have an higher force constant: acetylene, ethane, ethene? All have same values: acetylene, ethylene, or ethane. So, what will the answer to this? So, what is Hooke's law? We already discussed what is Hooke's law. So, we have discussed mu is equals to 1 upon 2 pi under root k by mu. So, what is k and what is mu? So, k is your force constant, mu is your reduced mass. So, this is your Hooke's law. Now, you know what is acetylene? Acetylene is the one with the triple bond, that is CH triple bond CH. What is ethane? Ethane is your C2H6, that is CH3CH3. And what is ethylene? Ethylene is your double bond CH2 double bond CH2. So out of these three, single, double, triple, which will have a higher force constant? So among these triple, single and double, force constant is also known as how strong a bond will be. So it is also tells you about the bond strength. So we know bond strength of triple bond is higher. Then comes your double bond, and then comes your single bond. That means the force constant will be higher for acetylene, then ethylene, and then your ethane. So out of this, acetylene will have a higher force constant. Now next, aromatic CH stretching falls in the range 3100 to 3000, 3300 to 3200, 3000 to 2900, or 2650 to 2500. So it will be 3100 to 3000 centimeter inverse. Next, so I'll just delete this first. So just remember for the IR, if you are having an OH, NH, triple bond CH and double bond CH, in this case is the wave number will be in the range of greater than 3000 centimeter inverse. When you have the CH stretch, then it will be nearly 2900. When you have CH triple bond C or nitriles, then it will be nearly 2200. For C double bond CH2 carbonyl and CH2 double bond nitrogen, then it will be nearly 1700. But it depends. If it is ketone, aldehyde, esters, acids, it may have slightly different, but it will be in the range of nearly 1700 centigrade inverse. Then this was for your functional group region. Then there is a fingerprint region also in the IR that comes at less than 1400 centimeter inverse. So these values you should know for the different functional groups. So the aromatic CH comes at 3100 to 3000 centimeter inverse. IR spectroscopy cannot distinguish between cis trans isomers, position isomers, tautomers, or enantiomers. So it will be enantiomers. Why? See, if you will have tautomers, then what will happen? Ketone enol form. This is a keto and another will be enol form. So you know in both the cases the functional group simple. You can distinguish these two only you can't distinguish your enantiomers. Next, a CO molecule has a force constant of 1840. The vibrational stretching frequency for the same is in centimeter inverse. So just calculate and tell me what will the vibrational stretching frequency for the CO molecule. So we know this formula mu is equals to 1 upon 2 pi under root k by mu Now we know 1 upon 2 into 3.14 into under root k, it's given 1840. Reduced mass. How you calculate reduced mass? M1 M2 upon M1 plus M2. So for carbon and oxygen it's 12 into 16 upon 12 plus 16. So just solve and then it will give you the value vibrational stretching frequency. Next, in which region of IR molecule will show its characteristic spectrum? Near IR, fingerprint, far IR or functional group? So the characteristic spectrum is shown by the fingerprint region. Next, detection of the homonuclear diatomic molecules can be done through IR, Raman, microwave spectroscopy or none of the above. Anyone? What will be the answer to this? What are homonuclear diatomic molecules like H2, N2, O2? These are the homonuclear, same atoms. So, if you know, for IR spectroscopy, what is the condition for a molecule to be IR active? That means the dipole moment should be changed. There should be a change in dipole moment. That means they should not be equal to 0. And if you see in H2, N2 and O2, there is no change in dipole moment. Therefore, I spot spectroscopy can't be the correct answer. So the correct answer will be the Raman spectroscopy. As we know, in a molecule with a center of symmetry, like just see the example of CO2. It has center of symmetry. So in this molecule, those vibrational modes are Raman active which are IR inactive and IR active are Raman inactive. That is a mutual exclusion principle and all the homonuclear diatomic molecules like H2, O2, N2 as they have center of symmetry so they are only Raman active. This you have to remember. And in linear symmetric diatomic molecules is CO2. So when we talk about the CO2, you will have three stretches, symmetric stretch, bending and the asymmetric stretch. What does symmetric stretch means? When it is in the same direction. So here it is Raman active. That means it will be IR inactive. Then there's another stretch that is asymmetric stretch. Asymmetric means in different directions. So bending. So in bending mode, that is mu2, the bond length remain constant and thus there is no change in the. As a result, if bond length is constant, then there is no change in polarizability. Therefore, it is Raman inactive. Why? Because in Raman there is a condition that it should be polarizable. So it is Raman inactive while IR active. And in another antisymmetric mode, there will be increase in polarizability because it is in different directions. So there will be increase in polarizability in the one carbonyl that is neutralized by the decrease in the polarizability of the other. So these two are inactive while are IR active one. So these two are same, while in symmetric sets it is different. These are the three modes in case of the CO2. Next, molecules containing the vibrations without center of symmetry are, we already discussed, it will be both Raman and IR active. Next, the force constant of four diatomic molecules are given below. Which of the four molecules has the highest vibrational wave number? N2, F2, HCl or CO? Just calculate and tell me. See, we know the vibration wave number depends upon force constant and also on the reduced mass. So, it is directly proportional to the force constant and inversely proportional to reduced mass. So, if you want that vibrational wave number should be higher, that means reduced mass should be lower, and in case terms of the force constant, it should be higher. Now, out of these four, 450, 510, 18, 60, 22, 40. So, clearly in this case, as F is highest force constant, so it will have higher mu, and also check in terms of reduced mass. Calculate the reduced mass in case of N2, HCl, CO and F2. Because see, these are homoatomic molecules, but HCl and CO are heteroatomic. So you have to take other factor also in account. So both the factors, reduced mass and the force constant, has to be taken in account. So what will the reduced mass for the HCl? Or N2 or CO and F2? See, for mu, you need M1, M2 upon M1 plus M2. M1 into M2 upon M1 plus M2. See, for HCl, M1 will be 1. For chlorine, it will be 35.5. For carbon, 12 and 16. Similarly, for N2 and F2 can calculate. So just calculate the reduced mass, and after solving, you will see that reduced mass, whichever will be having lower, will have the highest vibrational wave number. So the correct answer will be HCl. Moving to next, what is the order of vibrational frequency for CCl, CBr, CC, CU and CH? So what will the answer to this? See, just now we discussed the reduced mass should be lower. In that molecule only, the frequency will be higher. So see, carbon is common, hydrogen, carbon, oxygen, Cl and Br is there. So out of these, which will have a lowest reduced mass? Simple, hydrogen. That means hydrogen mass is lower. That means vibration frequency is higher. So only the first option will be the correct one. CH, CC, CO, CCl, CBr. Next, the Raman intensity depends on intensity of source, concentration of Raman active group, polarizability of molecule, or all the above? So what will be the correct answer? All the above. Next, a molecule that obeys mutual exclusion principle, CNS, CO2, HCl, or CHCCl. So which will be the correct answer? We already discussed among these four. Correct, Moses. Moses, what will the answer to this? Which will obey the mutual exclusion principle? Which molecule obeys mutual exclusion principle out of these four? CNS, CO2, HCl, or CHCCl? So it is CO2. Why? We already discussed. If in a molecule there is center of symmetry, here, if in a molecule there is center of symmetry, then IR active will be Raman inactive, or Raman inactive will be IR active one. So in all this, center of symmetry is only in CO2. The correct answer will be CO2. Next, which of the following cannot be conserved during Raman scattering? Total energy, momentum, kinetic energy, or electronic energy? So it will be kinetic energy. Moving to next, using radiation of wavelength 4 into 10 raised to the power 3 angstrom, the first stock line appears at spacing 350 centimeter inverse from the Rayleigh line. Calculate the frequency of the first anti-stock line. So just solve and tell me what will the frequency of the first anti-stock line? Just solve and tell me. See here it is given wavelength. So wavelength is 4 into 10 raised to power 3 angstrom. So it will be 4. As what is the relation between wave number and wavelength? So it is inverse. So here 1 by wavelength, angstrom we will convert, it is minus 10, but in centimeter it will be minus 8. So after solving it, it will be wave number will be 25,000 centimeter inverse. Now we know to calculate the frequency of the first anti-stroke line will be 350 is equals to mu s minus 25,000. So from that you can simply calculate the frequency of the scattered radiation, that is mu s will be 25350 in centimeters. Is this clear? Is this clear up to this, Moses? Moses, you can unmute yourself also instead of texting. Is this clear up to now? Or should I repeat something? Next, the rotational Raman spectrum of 35Cl2 shows a series of stalk lines separated by 0.9752 cm inverse and a similar series of anti-stalk line. Calculate the bond length of a molecule. Just solve and tell me what will the bond length here. So it will be, see, you have to calculate the bond length. That means you have to calculate R. And here we know the separation is 4B. So 4B is given to be 0.9752. That means B will be 0.9752 by 4. That means your B will be 0.2438. See, now you know B, you have to calculate R. And we know for R you should know the value of moment of inertia I. So what is the relation between B and I? So we know I is H upon 8 pi square B into C. So now we know H is 6.6626 into 10 minus 34. 8 pi you know, B you already know, C also you don't know. So from here calculate I and tell me what is the value of I. So what was the value of moment of inertia here? So here I will be 1.1438 into 10 minus 38. So now you know I. So how can we calculate R? We know I is equals to mu R square. So from here R will be under root I upon mu. Meanwhile calculate mu for the chlorine. See for the Cl2, we know for Cl it will be 35.5 is your mass. So calculate 35.5 into 35.5 upon 35.5 plus 35.5. So from there, what will the value of mu? And also divide by the Avogadro number. So what is the value of mu? So here, R will be equal to under root 1.1438 into 10 minus 38, and after solving your mu will be 2.90 into 10 minus 23. So I will be 1, sorry, R will be 1.98 angstrom. Is that the correct answer? Next, HCl molecules absorbed the radiation at 2885.9 centimeter inverse by using a Boltzmann distribution. Calculate the relative number for the first vibration level at the ground level at 25 degrees Celsius. Suppose number of molecules at ground level is 1. So just solve and tell me what is the value. What is the answer? Take 5 minutes. Not 5 minutes. Take 2-3 minutes. Just calculate. It's simpler formula based question. So it will be E raised to minus delta E equals to delta E upon KT. We know what is delta E? Hc by lambda, or we can say because wave number is given upon KT. So substitute the values. E minus 6.626 to 885.9 upon what was KT? We already know it's 1.38 into 10 raised to 23, and temperature it is given in Celsius, so convert to Kelvin. So plus 273, that means 25 plus 273 is 298. So just solve, and the answer will be 9.247. So 245 into 10 raised to minus 7. That's the correct answer. Moving to next, the fundamental vibrational spectrum of CO molecule at the wave number 2138 centimeter inverse and the line which represent by the transition mu equals to 2 to mu equals to 3 at wave number 2091 centimeter inverse. Calculate harmonic constant, anharmonic constant, or dissociation energy. So, for solving it, I will take an HPP. So, just solve first, then I will solve it. So it will be omega E plus V minus omega E XC V plus 1 by 2 whole square. So this will be equal to the first one minus G0. Now it will be omega E 1 plus half minus omega E XC one plus half whole square minus, I'm just substituting the values. So it will be omega E. Now 0, we have plus 0, below 0. Then minus omega E XC 0 plus half whole square. Then just solve this. So it will be 3 by 2 omega E minus 9 by 4 omega E XC minus half omega E plus 1 by 9 omega E XC. So it will come, if you will solve this, so it will be omega E minus 2 omega E XE. That means it is given to be 2138. So this will be first statement. Now calculate for G is equals to G3 minus G2. So for this, what will be? So for this, it will be 7 by 2 omega E minus 49 by 4 omega E XE minus 5 by 2 omega e minus 25 by 9 omega e x e. So it will be 2091 equals to omega e minus 6 omega e x e. These two statements you have get. Now from these two, it will be 47 equals to 4 omega e x e. Then omega e x e will be 11.75 centimeters. Now we know 2138 is equals to omega e minus 2 into 11.75. So omega e can also be calculated and it will be 2151.5 centimeters. So we have calculated the harmonic constant, the unharmonic constant. Now, but how can calculate the dissociation energy? dE. So just calculate the dissociation energy. See, it will be omega e whole square upon 4 omega e x. Now just solve and tell me what is the value of dE. Just simply put 216 1.5 whole square upon 4 into 11.7. So after solving it, you will get the value of dissociation energy. Next, give appropriate position of characteristic IR bands in the following: acetone, ethanol, and this is acid COH, and one for the this part. So tell me, See, for the CH stretch, it will be 2960 It's a ketone carbonyl, so nearly 1700. We know for the OH stretch in ethanol, nearly 3000. Sorry, for the OH stretch, it will be nearly 3630 and CH stretch CM 2900. For the acid, OH will become at 3000 and for the carbonyl at 1700 to 1750. Similarly, for the ketone, nearly 1650, CH stretch at 3000 and carbonyl at 1700. Moving to next, give the approximate characteristic absorption band of CN group in IA spectra. So this will be the last question today. So tell me. See, all are amines, but some are primary, some are secondary, some are tertiary. Aromatic and aliphatic amines. So tell accordingly. See, for the first one, it is aniline. Then comes the diphenylamine. Then comes triphenylamine. Then is a simple CH3 NH2. Now tell me, what will the characteristic of the absorption band of the CN group? See here, this nitrogen is attached to a single carbon. That means it is a primary amine. Here, the nitrogen is attached to 1 and 2 carbon. That means it is a secondary amine. Here nitrogen is attached to three carbons basically. It is also it is a tertiary amine. However, it is a primary amine but an aliphatic one as it was aromatic one. Now, for the primary amine that is aromatic, it is 1340 to 1250. Then for the secondary amine, it is 1340 to 1280. The tertiary amine, it is 1300 near 1300. And for the primary amine, it is 1200 near 1200. So that's all what we have discussed. So Raman is a scattering spectroscopy. So here we talk about the stroke and the anti-stroke and the relay scattering. So basically, if the molecule goes to the excited state and comes to the same energy level, then it is relay scattering. When it comes to lower one, it is Stokes scattering. When it comes to the higher one, it is anti-Stokes. For the Stokes, h mu minus delta E, energy is h mu plus delta E for the anti-Stokes and h mu for the relay scatter. Then intensity of the relay is higher. The left to relay is Stokes with a lower wave number. Right is anti-Stokes with a higher wave number. Then for the Stokes line, it is delta mu is equals to mu naught minus mu s, while delta mu is equals to mu s minus mu naught for the anti-Stokes one. Then we discuss about the Hooke's law. Then mutual exclusion principle. Suppose for a center of symmetry molecule, Raman active will be Raman inactive and vice versa. Then we discussed about the harmonic constant, how we can calculate anharmonic dissociation energy. Then some stretching frequencies of different functional groups. Here you can also take this in account. See, 3000. What comes near 3000? OH, NH, triple bond CH. That means sp3 hybridized CH, sp2 hybridized CH. Then CH is at 2900, C triple bond C stretching. And nitriles at 2200, carbonyl we already know 1700, and 1400 is your fingerprint region. And this is your functional group region. So that's it. That's all for today. Do you have any doubts? Any doubts? Yes, Moses.
Is one expected to, first of all, thank you so much for the presentation. I am very grateful.
Okay.
I am talking from Kenya. Kenya is in East Africa.
Okay, you're talking from
And
East Africa. Okay.
yes, Kenya.
Kenya. Okay.
My question is one expected to know the characteristic absorption bands of different bonds
Okay.
offered, or they are available in data books?
They are available in the data books as well. Also, maybe in the next class, I will share you the chart also so that you can know. Well, you can take the screenshot of this also. Just a second. Just a second. Mm. Here, different functional groups are there. But exact value for the ketones, acids, and esters, maybe in the next class I will share you the chart so that it can be easily understood for you. That is fine.
Okay,
Because if you
it is
talk
okay.
about, yeah, also it will be available in the textbooks as well as in the internet also. There is a chart where different functional groups observe at different wave numbers. Like if you take about carbonyl, so in carbonyl you will have ketones, acids, esters, aldehydes. So they all generally comes at 1700, but it may vary depending it is ketone, acid or esters. Similarly, you see here, we talk about amines today. So in amines, you are having primary amine, secondary amine and tertiary amine. So all the amines are having different absorption value. Like take a look. For the primary aromatic amine, it generally comes at 1250. However, secondary amines comes at 1340 to 1280 region. Then tertiary amines at 1300 and primary at nearly at 1200 to 1100 or 1050. So these are the different range. You only should remember that a near range, not exact values. Generally, they will ask in the range only. Like if you
Okay,
see OH group generally you will have a broad peak, and for the OH it will generally comes at 3300 or 3600 depending whether your OH is doing intramolecular hydrogen bonding or intermolecular hydrogen bonding. That factor also depends. So in that case, OH comes at nearly 3000. If you talk about the CH stretch, so it is generally 2900. Like for the nitriles, CN, so it is at 2200. So different functional groups have different absorption.
okay. And I have a concern that I would like to be addressed. I have tried to register for exams, but the system tells me that my phone number is invalid throughout. It has been a very difficult moment for me to register.
Okay, so maybe you
I
can just
I have
contact
written
the mail.
I have
Yeah.
written emails several times, but what I have gotten, which I'm grateful to, is the extension of registration time. But every time I key in my phone number, the system tells me that my phone number is invalid.
Okay. Actually, this I can't solve it, but you can maybe one thing you can do, mail that NPTEL portal also. There will be a helpline mentioned in the in your portal also. There will be a helpline. So just mail to that helpline, and also you can mail the respective PI. That is the
Okay,
professor
I'll
IT,
look
the
for
lead
the help.
professor. Yeah. Just mail him
I'll,
also for the same so that he can help that.
I am
If
not seeing your presentation screen. It is blocked. So in case there is something you are presenting on that side, I'm not able to see.
now you can see
No, not yet. It is blocked. It has so many messages.
which
The
presentations you are
presentation,
telling.
yes, it is not clear. There are so many things. I mean,
Like what? Exactly what topic?
I can see your logo and your name, then my logo and my name, and then that is the same one which has been spread in one other side of the same screen. So I can't see whatever you are doing on the other side. Just in case you are presenting anything.
No, just now I'm not presenting anything, But earlier you
Okay.
were seeing it?
I'm seeing the presentation screen, but it has things which do not present any information. Just I'm saying that just in case you may have communicated any email or a
No,
phone
no,
number. It is
no, 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 no. I haven't.
oh,
Also, one more thing,
okay.
like I have, like all these videos and the slides will be shared to you also, so you can see.
Okay.
If you may have missed it, you can see in the YouTube's on YouTube also. There is a
Okay.
channel. And meanwhile, do you have any other question related to some concept or something so that I can help?
The calculations are too much.
Yeah, that is there. It will take some time, but
The
it is very
calculations are
straightforward. But the calculations are very straightforward. Simply see, if you have to calculate rotational constant or moment of inertia, they're interconnected. So you know the formula. B is h upon 8 pi square IC. Then I is mu r square. That is mu is reduced mass, r is your distance, bond length basically. So calculation will take time, but it is very straightforward.
okay.
Yeah. Anything else?
I'm very grateful for the presentation.
Yeah, thank you. Like all the other sessions are clear to you? Like the past three sessions?
No, I've not been able to join because I was not conversant with the timeline. So I have missed the
Okay.
first three.
Okay. So
Yes.
just I will I have like first three sessions are already shared in the YouTube channel. So this also I will share. So just you can take a look in the YouTube channel. You have the link for that? Do you
I
have the
will
YouTube link?
find out.
Maybe I can share you also in the chat.
Yes, I'll be grateful.
Just a second. See, this is the link to my first video. So from here, just access all the videos.
Okay.
Yeah. Or maybe in the next session on the Tuesday you can join. And if you have any doubts, just collect everything and you can ask on Tuesday. And even you can ask on the this is a portal, problem solving session portal in your portal. So there also you can ask the question. Otherwise, you can ask me directly on Tuesday session.
Okay.
Yeah. Thank you.
Thank you so much.